Go. Okay. All right, so I want to start the review with 2.4. And just a reminder that the topics we're covering tonight and the problems the TAs are going to do on Thursday were based on the requests that you guys gave. So some of the sections that are on the test or not on the review, make sure you look at the study guide. So from 2.4, I'm doing pretty much one of each type of problem that you had in that section. This first one, we're given a graph, and it is annotated maybe a little bit. It says use the graph to find a delta greater than 0 such that for all x, the absolute value of x minus a is strictly between 0 and delta, implies that the absolute value of f of x minus L is less than 0.2. All right, so the function here is labeled. That black line is the function y is equal to 2 times the square root of x plus 1. So we have that information too. And then we have some green lines here that are actually showing something that was given too. Notice that the dot that's on the curve is at the point 3, 4. And you're given the definition, by the way. I don't have it on here. But you're given the precise definition of a limit, and that's where a lot of this notation is coming from. So I don't have it right here on the screen, but what is the 0.2? What is that in the precise definition? It's epsilon, okay? And so just getting familiar with what we have here, the epsilon of 0.2, our limit is equal to what for this one? It's the y-coordinate of the point. 4. Good. And so the distance of epsilon is showing up in the green there. We have 4 plus 0.2, which is 4.2. And then if we take 4 minus 0.2, we get the 3.8. So just kind of getting our bearings here. What we're trying to do is determine the delta. So the delta has to do with the y stuff or the x stuff. X stuff. Epsilon has to do with the y stuff. So now we're dealing with the delta. Here's the x and the a. What is the a for this problem, by the way? Can you determine it from the graph? 3. So that's the x-coordinate of the point. All right, so now getting down to the nitty-gritty, we're going to actually try to figure out the delta. So the delta is like the distance from the a, in this case 3. And if we have a nonlinear function, these distances between the blue lines and 3 are not the same. And so we need to determine each of these distances that are shown in these purple lines here from 3, and those are our candidates for delta. Anybody remember which one we take, the smaller or the bigger one?
Smaller.
The smaller, good. Because that'll ensure that when we map it back up, it's within an epsilon of 0.2. Okay, so to work on this, because we're given the function 2 times the square root of x plus 1, we can be pretty precise here. Usually I tell you to do this for a certain number of decimal places or something like that. Let's see. Oh, no, this works out exactly, so we don't have to do that. Okay, we're going to use the function here to determine the x coordinates. So if we find, this is getting really messy, if we erase some stuff here. So let's figure out what these x coordinates are that correspond with the blue lines. Let's figure those out. And then we just subtract 3. And then we figure out what those distances are, okay? So using the function, the y-coordinate of this point right here, I'll just label it A, is what? What's the y-coordinate of that point? 4.2, okay. So what we can do to figure out the x-coordinate is we set y equal to 4.2 and then write in the rest on the right hand side 2 times the square root of x plus 1, and then we can solve for x, right? I kind of chose an unfortunate place here where it gives me no place to work, so I'm just going to work up here now. So let's divide by 2 and we get 2.1, and then what should we do to both sides? Square? Okay, so we're going to take 2.1 squared and we get 4.41, and then finally to finish this, what do? Subtract 1. So x is equal to 3.41. Alright, so this x is 3.41. And so we'll figure out the distance is really easy, it's just 0.41. But again, because it's a nonlinear function, we're not going to get the same distance on the left-hand side, so we got to do that one too. So let's just do that. It's basically the same procedure here. And I'll do the work off to the side. So what is the y-coordinate that corresponds with this point B? 3.8. And so instead of our 4.2, we have 3.8. And then we do the same algebra steps. So we'll divide by 2 and get 1.9. Then we'll square both sides and we get 3.61. Subtract 1 and we get 2.61. Okay, so we scroll down here a little bit, and now I'll start writing some stuff. So delta is going to be the minimum of the distance between 3 and each of those points. So since we have the graph here and we see that 3.41 is bigger than 3, I'm just going to take 3.41 minus 3, and then I'm going to take 3 minus the x-coordinate below it, 2.61, and we're going to take the minimum of that for our delta. So we already did the subtraction for the first one because that was easy, 0.41, and 3 minus 2.61 is 0.39. So what is our delta? 0.39. Good. So delta is equal to 0.39, and we're done. So that got kind of messy. Sorry about that, but any questions?
And you'd be given that y equals by taking?
Yep. Yeah, because I don't think we did any where you estimated with a graph. So, you know, it'd be more similar to what you had on homework, which is more like this, yeah. And maybe it wouldn't be exactly this problem if I gave one like this, but maybe instead of labeling the graph or something, f of x, let me use like a highlighter or something, so maybe the f of x in here would be where you actually see the function listed, like inserting a 2 times the square root of x plus 1 in there. And so it could be changed up a little bit, and that's where that precise definition being given is useful, because then you can map stuff up and say, oh, well, that's what the f of x is. And you don't have to show your work just like me. There's a lot of ways to show your work for this that are correct. Just make sure you're writing something down and trying to do your best you can to show your work instead of just an answer. So you need to show some work here, but that work could be a lot of different things. Other questions? Okay. Are you sure? Because I need to stop the recording when we're done. Okay. Wow.